So in the second video for section 10.3, I gave you a mystery formula that's in red in the bottom right-hand corner. And I said if you were dying to know where it came from, that I would explain it in this optional video. So you can absolutely ignore this video if you're not interested at all. All right, so that formula comes from a rule that we have in trigonometry called the Law of Cosines. So if you've never heard of it, let me explain what it is. So the Law of Cosines is kind of like the Pythagorean Theorem, but for not a right triangle. So let's draw an oblique triangle, a triangle that does not have a right angle in it. And let's say its three sides are lowercase a, b, and c. And then we label the angles across from each side with a corresponding capital letter, which only gets confusing for angle C. It's a capital C. All right, so we know the Pythagorean theorem says a squared plus b squared equals c squared. The law of cosines starts off that way. I'm going to write that with c squared equals a squared plus b squared. But because it's not a right triangle, there's this extra bit that comes with the law of cosines, which is 2 times a times b times cosine of the angle c. Okay, so whatever side length is being squared by itself over on the left-hand side, its corresponding angle ends up in the cosine on the other side of the formula. Okay, so this is the law of cosines. And if you're dying to know where that formula came from, Google it. So let's see. Let's see what this has to do with vectors. So instead of sides A and B being just sides, I'm going to draw them as vectors. So let's say this is vector A and vector B. And I've drawn them tail to tail. So we're going to rewrite those as vectors. All right. So those side lengths are going to be the magnitudes of A and B, right? So magnitude of A and magnitude of B. All right, and then that angle C that's between them, that's our theta that we were talking about in section 10.3, the angle between them. So I'm going to erase C, and I'm going to call that angle theta. So the last thing I'm going to rewrite that side length C. I'm going to think about that as a vector. Okay, so if I rewrite that as a vector, draw that as a blue vector, and just for fun, I'm going to make it point towards A. Actually, it doesn't really matter. That vector we can think about, remember when you connect tip to tip of vectors, that's actually vector subtraction, and it points towards the positive vector. So I'm going to think of vector C here as vector A minus B. And then that side length of the triangle would be the magnitude of A minus B. Okay. So now that I've gotten everything written in terms of vectors and their magnitudes, let's rewrite the law of cosines. All right, so the side C squared is the blue one, right? And that's now vector A minus B. So I've got that in magnitude, so we're getting the side length of the triangle, so it's still the law of cosines, and that's being squared. And then side length A squared is going to be the magnitude of vector A squared. Let's see, B, magnitude of B squared minus 2 times A, which is that magnitude, B. And then cosine, we said that angle C, we rewrote that as the theta that we wanted in our formula. Okay, so you can see a little bit of the formula down in the bottom right starting to show up, but not a whole lot. The next thing I'm going to do, our last property of the dot product in the first video said that if you have magnitudes being squared, that's the same as dotting a vector with itself. Okay, so A minus B is a vector, and if I dot it with itself, that's the same thing as its magnitude squared. That was just one of the properties of our dot product. So I'm going to do the same thing for A and B over here, A dot A and B dot B. And then the rest of this is just going to hang out for a while. We also had a dot product property that said that dot products distribute over addition and subtraction. If you take that kind of a step further, it means that the dot product will FOIL out the same way multiplication does when we're just multiplying out binomials. So on the left-hand side of this equation, we can make this into A dot A minus A dot B minus B dot A, and then plus B dot B. Okay, and then everything on the right-hand side, I'm just going to copy. All right, let's see. Ooh, that looks like a mess. But notice that we have a lot of stuff on the right and the left that can cancel out. Remember, a dot product is just a number. So I can, let's see, I can subtract whatever a dot a is from both sides, and that would cancel out those values. And I have a b dot b on both sides that also cancel out. And these two guys right here, a dot b and b dot a, we had another dot product property that said that those are the same thing. So I'm going to write those as negative 2a dot b. And that's actually all that's left over on the left-hand side. And on the right-hand side, all I have left is a negative 2 magnitude of a, magnitude of b, cosine theta. And let's see, you can kind of see the formula coming out now, right? All I'm going to do is divide both sides by negative 2 magnitude a, magnitude b. Do it over here, negative 2 magnitude a, magnitude b. And I get the negative 2's to cancel out. And you have your formula. Over on the right, all I've got left is cosine theta. And on the right, I've got a dot b over magnitude a, magnitude b. And that is why.